Afternoon, everyone. Good morning, evening, afternoon, everyone. Thank you all for joining us live or on demand. We hope you're all having a great week and that you enjoyed the holidays. Happy New Year to everybody. My name is Brandon Rees, Product Marketing Manager here at EMQ. And today, my colleague Ernest Russell, who's our Technical Content Manager, and I are excited to talk to you about how MQTT is powering the next generation of EV charging. Some quick housekeeping items before we get started. Today's webinar will be an hour long with 45 minutes of presentation material and 15 minutes of Q&A at the end. We ask that you please use the Q&A tab at the bottom of your screens to submit your questions live. We will try our best to get to all of them. If for whatever reason we can't, we will be surely to follow up with you afterwards with those answers. And lastly, a recording of today's session and a copy of the slide deck will be shared with you after the webinar. So with that, next slide, please. Wanted to go ahead and start off by talking about the multifaceted landscape of establishing charging infrastructures and the challenges for electric vehicles, which is a crucial part for the wider EV ecosystem. First up is the financial aspect of it. You know, it's no secret that setting up this infrastructure demands a significant upfront investment. So, you know, finding the right investors and developing sustainable funding models is not just important, it's essential for, you know, the widespread adoption of electric vehicles. Moving on to the operational challenges, the two key points stand out. You know, one is the interoperability, the need for universal language between different charging stations, electric vehicles to ensure a seamless experience, you know, with all the different vehicles and charging protocols and things out there. The other is scalability. You know, with the rapid growth of EV demand, it's really crucial that our charging infrastructure is ready and being able to take on and scale as quickly as the market is growing. On a societal level, we're looking at challenges of urban planning and space constraints in cities. You know, finding the perfect spot for these different stations, and not to mention navigating space limitations, and demands close coordination with city planners. So space constraints, knowing who to work with to be able to get these things off the ground. Then there's the aspect of things like user awareness and education. We need to ensure that potential EV users, you know, new ones that aren't familiar with the space, like myself, for instance, who don't own a vehicle yet, but plan to in the future, be well informed about how EVs and their charging processes work. And finally, on the technical side of things, you know, we're dealing with a rapidly evolving technology landscape. So, as I mentioned earlier, with more and more vehicle manufacturers getting into the space, rolling out their own EVs, their own charging ports, their own dedicated stations, you know, it means that we need constant updates and investments to stay in sync with the latest charging tech and compatibility with the different models. The other is grid integration. So also comes into play here. And, you know, how do we integrate with these different stations with the existing power grids without causing things like overload issues? And let's not forget about cybersecurity. As you know, these infrastructures become increasingly interconnected, safeguarding user data, payment systems, and the network's integrity really becomes that much more important. And each of these aspects present its own set of challenges, but you know they also offer opportunities for innovation and advancements in the EV charging infrastructure space. Next slide, please. So moving on to now that we are familiar of the underlying challenges within the space, do want to do a brief overview of MQTT. Please note this is not a deep dive, so we will be touching on just very high level topics here. But know that we do have a bunch of material that does take a much deeper dive on these things, whether you're talking about blog series, dedicated university sessions, or even overview videos. So please do take a look after we cover this slide. But MQTT was originally developed by IBM in 1999, and it once stood for Message Queuing Telemetry Transport. Today, it just stands for the acronym. They've done away with that. And at its core, it's a very lightweight publish-subscribe messaging protocol with an incredibly small code footprint. So what that means is that it's been optimized for efficiency, and it doesn't consume a lot of hardware resources, you know, things like processing power, energy, or memory. and can run really stably in remote or high traffic areas that are known to struggle with things like low bandwidth or unstable networks. Also important to note that the protocol is incredibly reliable. It provides three different quality of service levels, 0, 1, and 2. Um, has session awareness through persistent connections, things like keep alive, last will and testament, as well as retained messages. So if you're a new subscriber and you join a new topic, you won't have to wait for the next update. You will get the last retained message. And all of these things together help ensure that message delivery um, is done and met appropriately in the challenging conditions, which makes it well suited for most IoT applications. It is also very well equipped for large scale IoT deployments. Internal benchmarks, for instance, for EMQX, have been able to scale up to 100 million concurrent connections, which realize is much more than folks probably need. But we thought it necessary to provide that overhead as the world becomes more interconnected. But the way that you're able to do that is with the publish subscribe model. It decouples the direct connection that is typically between the senders and receivers, and essentially stands as the broker for traffic between the two, the cloud and the device. And what this does is it reduces the network traffic and resource utilization. So instead of having that direct constant connection, you have that decoupling, which lets you scale those numbers up much more to get around things like bandwidth. And in addition to ensuring message delivery, QoS also enables things like customization of message delivery based on your application requirements, which further optimizes performance. And lastly, it has broad support for various programming languages, which is especially important when dealing with diverse IoT ecosystems that consist of devices and applications that were developed using different languages. And the EV charging space is no different, plethora of different options out there. So having a solution that can harmonize and bring those things together is really important. And ultimately, having this simplifies the integration process between systems and platforms. Next slide, please. So revisiting some of the key points that we've covered, I wanted to briefly recap the advantages of MQTT in the context of EV charging infrastructures. So as we touched on earlier, MQTT's integration, with cloud platforms is seamless, and it's really vital for managing EV charging systems efficiently. Echoing a point earlier, the low resource consumption of MQTT is advantageous for charging stations, especially in environments that have those limited resources. So if there's only a certain amount of space on the device, more often than not, given that the MQTT protocol can take up to just 2 bytes, you won't necessarily have to worry about that working with your solution. And highlighting again the robust fault tolerance. So MQTT, again, ensures reliable and real-time monitoring and control, which is essential and dependable for EV charging networks. And its ability to support a massive scale, managing up to the 100 million devices that I mentioned, it aligns perfectly with the growing demands of the EV market, and it should provide years of headroom to be able to hit those baselines. So to sum it up, MQTT, by offering things like efficiency, reliability, and scalability, it's really indispensable for evolving the landscape of EV charging. And with that, I would like to hand things over to Ernest to take you through some comparisons.
Thanks, Brandon. Good introduction to the protocol, and so I'll just recap a little bit and talk about how and why MQTT has become the premier protocol for IoT. Okay, we in this industry as well as many others, when we talk about the life cycle of EV cars and charging, there are different types of devices, some legacy, some new devices, some that may communicate in a proprietary way. So how do we make that choice? right? Of what is the right protocol to use when we're combining again legacy equipment with new equipment, when we have equipment that is dispersed regionally or even globally across the world. Some of these sites may not have the best connections and bandwidth. So we're going to talk to you about how we can overcome some of those challenges, not just in the charging industry, but around the life cycle of connected vehicles. And so to start off, let's consider one of the most common protocols, right? HTTP or Hypertext Transfer Protocol. Many are familiar with that protocol. Most browsers use this type of communication. And as Brandon mentioned, these many of these remote devices are very either network constrained or resource constrained, meaning maybe they don't have a lot of CPU, a lot of memory. They may not have a lot of storage, but you still need that reliability of being able to pull in that sensor data. And in these cases, when we're talking about charging, the charging community, charging piles, monitoring these stations, communication ends up being very often, very frequent, and in burst, right? So how do you manage that? Um, let's talk about the connection establishment first. So with HTTP, there is a TLS handshake that must take place, right? So which is the client acknowledging the server acknowledging the client, and then together establishing the cryptographic algorithm that they'll use to communicate. And these are established with session keys. So in HTTP, each connection, each time our device communicates on the network, that handshake has to be done. Versus with MQTT, that handshake is done initially. And so subsequent to that, we can just connect and send data. We don't have to do such a tedious handshake mechanism for each connection, which ends up making MQTT more efficient and in these scenarios where we're again connecting frequently and sending bursts of information. And so um, we, uh, Brandon mentioned that MQTT it uses a publish subscribe model, right? Which in turn separates the need for the client and the server to be attached directly, right? Our MQTT broker sits in the middle and has an established connection with both sides, whether that's your the cloud or that edge device, that edge sensor out in the field, right? So it creates a decoupling where all devices do not need to be aware of each other, but all devices can communicate based on the schema that you choose. And so HTTP does have its advantages, but when we're talking about, again, sites that are regionally dispersed, globally dispersed, may not have the best bandwidth or internet connection, MQTT really shines in that model. And again, just to go over some of the mechanics. So with HTTP, usually the client has to initiate the connection from the server. right? So each time your client, and say that client is a sensor at your charging station or within your charging network, it has to reach out to the server, establish a communication, and then that channel is able to be used to share data. Okay, but again, with MQTT, that process, that handshake, occurs much quicker. And when you think about the scale, Brandon mentioned, hundreds of millions of connections. And so when we get to that scale, and we'll talk about how scale affects this infrastructure and how MQTT can help facilitate scaling of many devices. So that's HTTP, but then there are some other protocols that have been around that are worth mentioning. You see here we have a co-op and lightweight machine to machine language. Co-op co-op is COAP. It actually follows a request response model very similar to HTTP. And it is good also for resource constrained and low power networks. But again, MQTT ends up being more efficient, especially when sending very frequent bursts of information. And then also the case, let's say with MQTT-SN or MQTT for sensor networks, we're actually able to allow that device to sleep, conserve battery, and connect and send information in burst when it wakes. So again, a very efficient model for remote sensors in the field, battery powered sensors. Another advantage MQTT has when compared to other common communication protocols is not just the quick establishment of the connection, which is done initially at the first time, but also the low overhead as the information exchanged with MQTT. It uses a binary format, minimizing the size of the messages and reducing network utilization. And so, very efficient communication, even when we have a poor connection. And so that leaves us with machine to machine language, which does also have its advantages, mainly when it comes to device configuration. Machine to machine language was established for that. It uses a publish subscribe model, also similar to MQTT, but it is more tailored for device management more than scaling of numerous types of devices and a large number of devices. So again, MQTT really shines when we're talking about scale. And I'll give you some specific examples of that from a couple of our customers. So now that we've talked about what MQTT is and some of the advantages of the protocol. So now let's talk about the connected vehicle lifestyle, because this technology isn't just about charging infrastructure. That happens to be our focus today, and a strong point of growth that we've seen over, I would say, the past 2 years. But I really want to highlight the complete life cycle and connectivity that's provided with MQTT, because it really extends the value of the vehicle itself, both for manufacturers, for distributors, for charging companies, for charging infrastructure, and for connected vehicles themselves. And as we move into smart cities and vehicle to everything communication, MQTT really sits at the heart of that. And so I'll give you some specific examples of MQTT used in a smart factory, MQTT used in the life cycle of the car for over-the-air updates and car telemetry. And then, of course, the charging infrastructure itself and the benefits that MQTT provides when it's part of that infrastructure. So let's see what that looks like. So starting with the automotive smart factory. And we've been involved with many manufacturers this year. Again, not just in their vehicles when they hit the road, but integrating that technology right into the factory. Scania is one where MQTT allows for real-time monitoring. So imagine in your OEM data center and your workshop, you have machinery, you have paint sprayers, you have robotic arms, you have PLCs that are monitoring different environmental factors, different factors involved in the manufacturing process itself. And so by integrating MQTT, it allows for real-time connection of this diverse range of devices. And so what we see here in this graph or this infographic on our right is starting at the bottom in the workshop, again, directly being able to pull data from those PLCs, allowing efficient data access from various equipment. And in some cases, sometimes that data needs to be translated, right? It's not always available in native MQTT, and that's okay. That's okay. We have a neuron that can help with translation. We have different libraries within neuron that help with that translation, whether it is a legacy technology, OPC Modbus. So it's I would consider it a neuron and an edge industrial protocol gateway, right? So the different protocols that are out there that you're already using, it's a way to bring that data into your infrastructure and into your cloud, right? Because at the end of the day, in most of our workflows, that's where the data processing is being done, right? So it's not just about making that sensor data, that PLC data available. It's about securely bringing it into the cloud where you can apply different maybe AI or deliver that in real time to a database so you can look at trending, create alarming and errors. And so it really is about again the integration from edge to cloud and reliably being able to message that data, not just reliably, but really efficiently. And that's where the power of MQTT comes in. And so let's consider this use case, that automotive smart factory, that first step in the life cycle. And if we consider that the first step, the next step, the second step would be vehicle to cloud communication, right? So after that vehicle leaves the factory, there's still, especially with connected vehicles, there are thousands of data points that are available to us. And we have to decide, or you have to decide within your business what data is important to you, and which data you want to bring into the cloud, right? So you may not want to bring everything from the car in, but you have access to that data, whether it is information from the CAN bus, information that's sent over UDP, information that is available over the MQTT protocol. And so here too, we see some of our other tools highlighted, like NanoMQ and integrating with eKuiper to connect edge to cloud. And I think this would be a good time to mention our integration with Quick. So EMQ is proud to be the first MQTT broker to support the use of Quick or MQTT over Quick. And what does that mean? Quick is the newest or the underlying protocol for our next HTTP communication, right? And the reason for that is Quick is very good with keeping and reestablishing a connection when switching networks, right? Which is very common with phones, with tablets, with mobile devices, and especially with cars. Let's think about it. As even as you leave your home, right, you may be traversing networks going from Wi-Fi to satellite or satellite to cellular. And so how do you manage that switching of networks while also retaining messages and data reliably? MQTT over Quick. And the advantage to that is with MQTT over Quick, the data connection is carried separately over the data itself. And so the data connection can actually go away and come back, or go away and come back as a different IP. And with the Quick protocol over UDP, it really does not care, especially in comparison to the same client operated over traditional TCP/IP networks. And so we do have benchmarks of this, as Brandon said. Our company has been really good with providing blogs, with providing step-by-step tutorials. So as you start and continue on your IoT journey, make sure you go to our site, emqx.com. We actually just revamped the site to make sure that it's easier to navigate, and those resources are readily available for you. Whether it's our MQTT University, where we cover everything from the basics of MQTT to integrating with different databases and clouds, launching Kubernetes or Docker containers. We have many deployment options and many resources to help you on that journey. So make sure you visit our site and continue to follow our monthly webinars. And so back to the vehicle to cloud communication. Again, it's very reliable. even over those spotty networks, thanks to MQTT over Quick. And also, again, the part of the key here is the data availability and processing in the cloud, right? So to be able to take that real-time vehicle data, environmental data, and provide that to your backend systems. So in step two now, we already have, when we talk about the life cycle of the vehicle, we have the information from the factory, right? And how that manufacturing process went, any problems that occurred. And now we have the information from the vehicle itself, thousands of data points to be able to analyze and become more proactive about correcting issues, fixing issues, identifying issues actually before it happened. So helps you move into more of a proactive state of maintenance versus reactive. So that's part two of the the vehicle life cycle. And so now let's get into the focus of this webinar, which is really more so of the charging infrastructure itself. And again, this is an area of growth with EMQ that we've seen rapid growth over the last few years, whether that is new charging stations in areas to support the growth of EVs, or an extension of distributed energy resources that are helping companies move more towards clean energy. And so we're talking solar panels, um, even wind power, and other clean energy methods, and we'll touch on that a little bit also. But in this diagram, you can see on the left that we have information that's coming in from the vehicle itself, and so that could be over MQTT, over MQTT-SN, or MQTT over sensor networks, which again is more efficient and prioritizes communication for battery operated devices or devices that may go to sleep. Supporting that information coming in from MQTT over the Quick protocol. And then two, any related private MQTT data, whether that be from the factory, the car, the charging station itself, all goes into our cluster, load balance. So again, we can do this at a very large scale, larger than most enterprises actually need at this moment. But that's been a huge decision maker for a lot of our clients is to be able to confidently know that they can continue to scale their infrastructure without running into issues. And so being able to bring in that data from the vehicle, from the charging station, bring that into our MQTT broker, apply that through a rules engine. And in most cases, this is an SQL-based rule engine. So very easy to use, and in a common context that you're used to using for data filtering. So you are able to filter that data and create data paths that are that facilitate the need for your business. So in this example, we're using a rules engine to separate and stream data to a Kafka cluster, which then makes that data available for different solutions on the back end, whether that be maintenance platforms, that could be an app for the vehicle owner themselves to see the status, the availability of local charging piles. That could be historical data. And since MQTT is secure in real time, we can even handle those financial transactions to be able to take care of the billing, the individual billing for each charging customers. And we have a few customers that are also using us to handle those real-time transactions. And so that is the really, it covers at a high level those 3 points of the EV charging life cycle. But again, we're in this webinar, and I hope you continue to join us as we explore different industries and topics. But in this webinar, I really want to continue to highlight some of our customers and solutions that we have in the EV charging space. And one of those is RavenVolt. And I work directly with Tim over at RavenVolt with this, and was very happy to hear their customer testimonial. And so RavenVolt proactively monitors microgrids to catch potential problems, create efficiencies. And so these are the distributed energy resources that I spoke about earlier, right? So that includes solar panels, a 24/7 monitoring systems, battery systems and charging systems, generators to keep those batteries powered, switch gears, and that information from the car itself that we spoke about. And so RavenVolt collects the data from these different data points from sensors, solar powers, generators, and every 5 seconds, it takes that data from these different data points, regionally, globally, at all of their sites, and transfers that data over a private cellular network to the cloud. Right. And so now RavenVolt has the ability, again, to get into the proactive monitoring, proactively maintaining their charging infrastructure and charge points. And so very happy, excited to work with them. And again, that's some of that data came from local SCADA or supervisory control and data acquisition systems. So all of these devices may not have been devices that can speak natively MQTT, but we were still able to bring in that data, make it available, and help them manage those remote resources. And as you can see from Tim, the one of the huge deciding factors was the scalability. And Tim said that he did trial some of the other top MQTT brokers out there, but that was really the decision maker, is the enterprise level support, being able to hop on a Slack channel, being able to hop into a Teams call and actually solve problems quickly as he was integrating this. And as he said, all of the setup was done right within the GUI, in the dashboard. So it made it really easy to implement. It was funny that he said it took him more time to learn how to use Kubernetes than it did to set up and configure our broker. And so I'm really proud of the ease of use and how far our GUI has come to be able to do most things without any coding. Just do it right there in the GUI. And also quickly, I'll mention EV power. So EV power, we've worked with. They're considered the largest independent charging operator in China, and we've worked with them to implement this technology into their charging network, into their charging piles, so that they can grow their community charging infrastructure. So again, now we've covered that those three the three steps of the EV life cycle. And so now I want to dig a little bit more into data integration and where the value and efficiency comes in when we're tying this sensor data into our cloud networks and into our backend systems. And many times that's done through our data integration. We've worked with and spent time making sure that we can easily integrate with many enterprise database systems, including relational time series and hybrid databases, and being able to create a simple rule to be able to migrate and retain that data, whether that's data coming in and storing that data into a database for you, or on the other end, being able to pull data from external systems like Kafka, MySQL, other HTTP-based services, being able to pull that in and integrate that with your infrastructure. So MQTT ends up being the glue that holds together that workflow. So you simply create the resource, the database you want to connect to, create the rule, and then create the action that you want to happen when that rule is triggered. So do you want to set an alarm? Do you want to set a notification? Do you want to trigger a data transfer? Do you want to trigger a notification in the app? Again, all of this is very easy to integrate and done right there, right there. This is a screenshot directly from our GUI, and so you're able to do it right there in our GUI, and makes the administration of it pretty easy. So efficient data storage, integrated rules engine, and real time and reliable transactions. And so now we have a few more minutes here before we get to Q&A. So don't forget to add those questions in the Q&A. I see we have a couple that have come in already. But now that I've introduced our data integrations, and I've talked about some of the advantages of having MQTT in the charging infrastructure, I'd like to toss to Brandon to talk about one of our latest integrations, which includes the integration of the Open Charge Point protocol.
No, thank you, Ernest. So as we explore the integration of EMQX Enterprise in the EV charging infrastructure, we're focusing particularly on the OCPP-J protocol. And this is short for Open Charge Point Protocol-JSON. And this is really a key communication protocol that bridges EV charging stations with their management systems. And really, the beauty of this protocol is that it lies in the foundation of JSON, which we all know is really renowned for its simplicity, flexibility, and at the end of the day, it makes it a really incredible user friendly, and it's a perfect fit for things like smooth system integrations. So now you may ask yourself, how does EMQX fit into this? So we've developed the EMQX OCPP plugin that adheres to the protocol's OCPP 1.6J standard. And this really ensures that smooth integration with those different charging points. And I guess you could think of this plugin as a translator and a traffic controller really rolled into one. And it manages things like message formats, conversion, and the direction of transmissions. And this all ensures that charging stations can easily connect to EMQX using OCPP over WebSocket. Um, but the cool stuff doesn't really stop there. This gateway brings a whole toolbox of features and different uh, features for charging devices. We got a solid transport layer for security and TLS, and SSL encrypted connections, several access authentication methods. So, including things like username and password and JSON Web Token or JWT. You will have precise control over who sends and receives messages. Managing clients will be drastically simplified by using things like our dashboard and REST API. And we've made sure that it plays really well with the MQTT protocol. And this ultimately enables the diverse applications. So being able to, work with existing systems and plug into, 40 plus different cloud backend processes. And the cherry on top is that, and kind of a repeat here from me, it does integrate seamlessly with third-party systems. And the way that we're able to do that is using our rules engine and REST API. So being able to leverage something we refer to as Flow Designer, which is very similar to a Node-RED, if you will, but it's a visual drag and drop interface, low code or no code interface where you can quickly apply rules and tie in different backend processes. So ultimately by embracing OCPP 1.6-J, EMQX Enterprise isn't just adding a feature. It's really boosting the ability to handle device access, data integration, for electric vehicle charging management. Next slide, please. And here we really wanted to speak to, don't just take our word for it. Wanted to be able to point to a number of different customers and data proof points to really speak to our momentum and traction in the space. Uh, there are a lot of leading brands within the space that have trusted in our technology and are reaping the benefits that we have covered in today's webinar. Some of the brands I'm sure you're all familiar with, the likes of BMW, Volkswagen, Lucid, and many more. And some of the data points wanted to speak with you that are listed on our website too, if you'd like to take a closer look. We do have 5 out of the 10 largest automobile companies as customers working with us today. 7 out of the 10 reputable EV startups, as I mentioned, Lucid being one of them. 50 plus automobile companies, 100 plus different car models, and at scale, 10 plus million EVs and cars that are actively using our solutions today. And another thing that I wanted to mention was that we recently joined the Connected Vehicle Trade Association, or CVTA. And this was a huge step for us because it really put EMQ right at the center of innovation in connected car technologies. And ultimately, what that means is it opened the doors to new business opportunities and collaborations in the field. And we've also become a member of the mobility data space community. And this is important too, because it aligns perfectly with our vision of enhancing things like global transportation systems, focusing on accessibility, safety, and efficiency through cross-industry, collaboration.
That's a great point, Brandon. And I can say that I spent months last year traveling to Detroit, to Ford, to talking with Toyota, talking with Honda, Scania, about the future of EVs. So we've been very connected to the industry, with our ears wide open, and our product suite has reflected that over the last year, right? With the implementation of MQTT over Quick, integration of the charge point protocol, and even our unique advancements with Neuron EX, and starting to integrate some features there that will particularly give some advantages to the automotive industry and connected vehicles. And so, if you're with us today, and maybe the charging infrastructure caught your ear, caught your eye, I like you to know that we are a complete solution for the life cycle of the vehicle, not just the charging, right? And so we have some great solutions within the charging space. But again, having those conversations, being involved in the industry, being involved in different trade organizations, and standard organizations like Oasis, we're really striving to help close the gap on data silos, right? Because that's what ends up happening, and that's one of the challenges that we're helping our customers fight head on, right? You have this data in the car, you have this data in the factory, you have this data at certain data points and sensors throughout the car, from the car to the factory. How do you bring all that communication together in a usable way? MQTT. And EMQX is the world's leading MQTT broker, and our commitment to connected vehicles, I would say, is definitely unprecedented. So glad to be a part of that industry, to get out there and talk to many more manufacturers to help get over that technology switch, because that's really where we are right now, Brandon, right?
Hmm.
It's a change in infrastructure from fossil fuels, oil and gas, to connected vehicles, integrating with the grid, integrating with mini grids, managing mini grids, communicating information uh, from these remote charging locations, right? This is fairly new.
Yeah.
And even though the MQTT protocol isn't new, it is emerged as the ideal solution to
Hmm.
be able to tie this data together. So we do have a couple questions here, but before I get into Q&A, I'd like to invite you all to our EMQ office hours. We usually do two webinars a month. We do one like this webinar where we dive into a particular industry or industry solution, and that's usually driven by myself or Brandon, and we want to help guide you through the industry challenges and how we tackle those. The MQ office hours is different. We do that once a month also. The next one is on January 23rd if you'd like to join us. And this is more of an open invitation where we open the doors to our office, and we want to hear your solutions. We want to hear about your IoT projects. We want to hear what you're working on. We want to hear what you'll learn about, what you want to learn about. And so our audience is very much involved in driving the conversation for our EMQ office hours. And actually, we've been giving away Amazon gift certificates based on participation in these. So it's been really growing and a fun project to be a part of. So I look forward to seeing you there. Join our Slack community. And we post a lot of our updates there also. So we will see you at our next office hours. And we do have a couple of questions here. And I'll leave up this slide with our contact information for a little bit while I cover some of these questions, while we cover some of these questions. But want to highlight that I know there are different audiences that are watching this. So whether you're implementing a solution, thinking about implementing a solution, or thinking about partnering with us on your solution and your vision, we encourage that. So here you can reach out to us for partnerships, support, sales, and just general questions. And so speaking of general questions, we do have a couple we can cover here before we go. And one was, in light of operational challenges like grid integration, how does MQTT contribute to harmonizing the EV stations with existing legacy power grids? You want to get that one, Brendan?
Yeah, I'll take that one, Ernest. I think MQTT plays a critical role in aligning EV charging stations with the power grids, and I think it's the facilitation of real-time data exchange, which we mentioned throughout the presentation here. But so we can adjust things like charging loads in response to the grid's capacity. So things like demand response. Um, Something that you really need to have that real-time capability. You can't just rely on near real-time that you'll see kind of spattered throughout the industry. And this will really help you prevent things like overloads, and it will ensure stable power supply, which I think is really crucial for those more densely populated areas. And it's, I guess you could think of it like having a smart system that's balancing your charging demands with grid capabilities. And I think it just makes the integration process a lot smoother.
Good one, Brandon. Our next one, I'm actually going to combine two of these for sake of time. What is the purpose of eKuiper, and what about Neuron? Where does that fit in? And so I'll talk a little bit about both. And so eKuiper is an edge tool. It's lightweight data analytics for stream processing, and it also runs on resource constraint edge devices. So you don't need a lot of resources to run this on site or at the edge. And the major goal is to provide a streaming software framework similar to Apache Flink on the edge side. And so eKuiper also has a rules engine that allows you to provide an SQL base or graph base rules to create IoT edge analytics. So makes it really easy and fast to build edge applications. And Neuron, where does that fit in? It's Neuron can help integrate with industrial applications like MES and SCADA. So again, when we talk about bringing in legacy data or data that is not natively in the MQTT protocol, Neuron can be a great tool and streaming processing engine to bring in that data, and makes it easy to integrate with cloud. We are compatible with every public cloud, so whether you use AWS, Azure, Google Cloud, Alibaba Cloud, private cloud, multi-cloud, hybrid cloud. We really make it easy to deploy in whatever environment you choose. And so we're right at time here. Thank you so much for your questions. And we hope to see you at our office hours this month, January 23rd. We'll see you then.
Thank you, everybody.
Thanks.